Hello everyone, welcome back to Think Lab by Saurabh. So this is the lecture 8 of our machine learning complete course. So in the previous lecture we have learned the Python, NumPy, Pandas, data cleaning, pre-processing and the exploratory data analysis. So today we are going to learn one of the most important practical concept in the machine learning, and that is the feature engineering. So feature engineering is the process of transforming the raw data into the useful features that can help a machine learning model to learn better patterns. So in the simple word, feature engineering means the extracting the more useful informations from the data that we already have. So a machine learning model learns from the features, so the quality of our features can have a major impact on the quality of model, right? So if you see here the complete pipeline of this feature engineering, right? So we will perform here, this feature engineering lies between the raw data cleaning, and after that we have to perform the feature engineering. So I'm going to write here the complete pipeline. Okay, so you can see here we are going to write here the complete pipeline here. So it will start with the raw data. Okay, then we take the data cleaning, and after the data cleaning we will move to the this feature engineering, right? So our goal is not simply to create a more features. Our goal is to create a meaningful features, and the good feature should contain the useful information about the problem we're trying to solve, right? So the question is, what is the feature? So before understanding the feature engineering, let's understand the what is the feature. So a feature is an input variable that provides the information to our machine learning model. Suppose we want to predict the price of a house. So this area, number of bedrooms, these are all the features. Okay, even the age of house, location. So these are the features. So this variable can be used as a feature, and the price of those house, that those house is what we want to predict. So therefore the price is our target, right? So everywhere in our machine learning course we write x as a feature and y as a target, right? So you can see I'm going to write here the terms of x and y. So you can see we are going to write here the x is equal to the features and y is the target. Okay, so everywhere we will use this nomenclature, right? So, we think of machine learning is learning the relationship between the X and Y, right? So now we are going to open the Google Colab and we are going to import all the necessary required library for doing the pre-processing. So for those doing the pre-processing, we are going to import the most important libraries like NumPy, Pandas, TensorFlow and Keras, right? So we are going to import all the library here. So first I'm going to write here this import numpy as an NP. Okay, after that we will write now import pandas as a PD, right? So I'm going to write here. So let me write those things. Okay. So first thing we are going to write here, import numpy as a NP. After that we will write here the panda as a PD. Then we will import the matplotlib as a pyplot as PLT, right? And after that we will take the sklearn for the pre-processing and we will perform the standard scaler and all. So now we are going to write here all the things here. So let me write those things here. Okay, so I'm going to write here numpy as a NP. We are going to import the pandas as a PD and also importing the matplotlib as a PLT, right? So this thing we are going to perform. So here the numpy NP is improved the numpy and gives the sort name as an NP. NumPy is useful for numerical calculations, importing the panda as a PD that import using the sort name PD, and panda help us to create the manipulate our data set. And the StandardScaler and MinMaxScaler are the pre-processing tools from the scikit-learn, and train test split will help us to divide our data into the training and test data. After that, we are going to create one data set here, right? So inside the data set, we are taking some variable name here, right? So first let me write the name of the data is the data, right? So inside the data we are putting the age, salary, okay? So I'm going to write here the age, salary, experience. This is a city names and this is a joining date, okay? So now I am going to run these things. So you can see we got the data, okay? This code is now working fine. So we have to create a data frame here, okay? After the creating the data frame, okay, we will first see the data, right? First we have to create a data frame. So how can we create a data frame? So we can simply write here, for creating the data frame we can simply write here the pd dot data frame, right? So now we are going to simply write here pd dot data frame, okay? So now we are going to write here the pd dot data frame, and this is our data, right? We are passing the argument as a data. So this is the value is the data, okay? This value is the data. Now I am going to run this code, okay? So I'm going to write here the df equal to pd dot data frame, and we got the this much data, right? So we have created this data. So I am creating a small data set so that we can understand the feature engineering practically. And our data set contains the age, salary, experience, city, and joining date. So notice something important. So this column have a different types of information. So age is the numerical, salary is also numerical, experience is numerical, city is categorical, and joining date is in form of date and time. So feature engineering allows us to convert this raw data into the more useful representations, right? So after that, after this part, we are going to perform here. We are going to inspect the data set. So how can we inspect the data set? So we can simply write the shape. Then we can check the columns, and we can also check the data types. And finally, we will see the head here, right? So in the one line of code, I am going to write here in a one cell all the four things. So I'm going to write here shape, columns, data type, and the first 5 row. Okay. So you can see here we got all the information about things. So before performing the feature engineering, we should understand about the data, and this shape tell us the number of row and column, and the columns attributes tell us the name of the features, and the data types tell us what kind of information in each column, right? So now we are going to for the feature engineering, right? So let's start with the numerical feature engineering. Suppose we have a salary and experience. So instead of using only two features independently, we can create a new feature that represents the salary per year of experience, right? So how can we create here? So we are going to create one new numerical feature we are going to create here. So simply I'm going to write here the df and salary per experience, right? So now we are going to create here, we got the data here. So finally we are going to write here the df, we are going to create here the df salary per experience, right? We have to write here. So basically what we are performing here, so we will just divide the salary by experience, right? So simply we are going to divide the salary by experience, right? So simply I'm going to write here, you can see we are writing here the salary per experience. We have to write here the df because we have to define the data frame here. So df the salary, and after that salary divided by per experience, right? So we will get here the salary experience and the salary expected, right? So you can see here this is the salary, this is the experience, and this is the salary per experience, right? So we got this information about, we got all this informations what we have written in this code here. Okay. So fine, here we are dividing salary by experience, and the result will be stored in the new column we call the salary per experience. So this derived feature we didn't collect any new data. So this, instead of extracting the additional information from the existing data, right? So this is the one of the most idea behind the feature engineering, extracting the useful information from the existing feature, right? Now we are going to use the ratio feature. So we can create another useful features using age and experience, right? So we can simply write here, we are going to create a ratio between the age and experience here. So we're going to take the age experience ratio. So after that we are going to divide by the age divided by the experience, right? And we are going to print here the age experience and the one new column. Okay, so we are going to write here the age experience and the age experience ratio, right? So you can see here we are getting the error here, this invalid character. Okay. So we have, okay, sorry, we have to run this code here. Okay, so you are able to see here we got this information about these things. Okay, we got the new information. So this create the ratio between the age and experience, and ratio are commonly used in the feature engineering because the relationship between the variables can sometimes be more informative than the original value, right? Now we are going to check the interactive interaction features, right? So interaction feature, another common technique is creating the interaction features. So now we are going to create one interaction feature here. So we are simply going to write here the df salary interaction, right? And we are writing here the salary experience and the experience salary interaction, right? So now we are going to create one new feature here. From the we are going to extract the data, and now we are going to perform these things. So you can see here we have to this salary or ratio we have already completed here in the above code, right? We already completed here. We are performing here right now. We have to take the salary experience, okay, and after that the experience interactions, right? So this thing we have to create here. So we basically we are multiplying the salary by experience, right? And here the resulting feature represent the interaction between these two variables. So now we are going to multiply those things. So let me write here. So you can see here we are going to multiply salary with experience, and we are going to store into the salary experience interaction, right? And then finally we are creating one data frame. Inside a data frame we are creating here salary experience and salary experience interaction, right? So after that we are going for the date and time feature engineering. So now let's talk about the one of the most useful technique, the date and time feature engineering. So currently join date we have to sort it as in the text. So how can we perform here? So we have to use this function pd to underscore data time. So this function convert our columns into the proper date and time format, right? So this is the joining date here. So now we are going to convert into the proper date and time format. So we will use here the pd to date underscore of this function we will use here. So now we are going to write those things here. So I'm going to write here pd to date time, right? So you can see here finally this is the date and time format we have got here. So now Panda can understand the individual component of the date, right? So now we are going to extract the year, month and date. Okay. So how can we extract the year, month, date? So we have already used this pd.get function here. So now we are going to use here the .dt.year, right? This is a property for the extracting the years. Then we will write the dt.month, that is a property for extracting the month, and after that we have to write the dt.day. So this is the property to extracting the day, right? So now we are going to write here. See, this is a joining date, and this is a joining date .dt.year, right? So we got the exact information about the joining date. So you can see here joining date, and this is a joining year, and this is a joining month, and this is a joining date. So this data is not present in our raw data. We have performed the feature engineering, and finally we extract the data. So here .dt.year property extracts the years, and .dt.month property extracts the month, and the .dt day property extracts the day. So now instead of retreating the date as a one piece of text, we have extracted a multiple useful information, right? So now we are also going to extract the day of work, right? So this we have to use here the day of the week, the day of the week property. So that's give us the day of the week, right? So here we are going to write here so joining date week, okay, and after that we have to put the joining date, and we are going to use here the function dt.week, right? So you can see here these are all the function here. You can see these are all the functions inside the data frame. So you can see here this is the joining date, and this is the joining date of the week, right? So we got all the information here. Okay, so the day of the week property give us the data of the week, and Monday is the represented as 0, Tuesday is a 1, and Sunday is a 6. So data information can be extremely useful in the areas such as sales, finance, transportation, e-commerce, and the user behavior analysis. So now we are going for the categorical feature engineering, right? So that's the most important here, the categorical feature engineering. So now let's look at the categorical features. So our city columns contain the text like Delhi, Mumbai, Bangalore. So most of the machine learning algorithm cannot directly perform the mathematical operation on this text labels. So therefore we need to convert the categorical information into the numerical representation. So one of the popular method is the one-hot encoding, right? So now we are going to perform the one-hot encoding, on the city here. So we will use the get dummy function, right? So get dummy function perform the one-hot encoding, right? So now we are going to write here, right? Now we are going to write here a df underscore decode, and we are using here the pd dot get dummies, right? So you can see here we got all the information about here. This is a city Bangalore, city Delhi, city Mumbai, right? We divided into the 3 columns, and we are putting here the 0 and 1, right? So if the person live in the Delhi and the Delhi column contain the 1 and the other city columns contain the 0, so it means the person is living in the Delhi, right? So this is the beauty of this one hot coding, right? So important question is that what is the one hot encoding? So it is a basically useful because it doesn't imply that Bangalore is a greater than Delhi or Delhi is greater than Mumbai. So we simply representing our categories membership numerically, right? So another interesting feature of engineering technique is called the binning, right? So binning means the converting the continuous numerical variable into the groups or interval, right? So we are going to use there the binning, right? So you can see here for the binning part, now we have to just right here, now we are going to define the beans here. Okay, first we have to define the beans. So beans is a variable defined by that the boundary, right? So we are basically defining the boundaries here. So first we in the beginning we are going to define the beans. So here we are going to define the bean as a 0, 25, 60, 40. Okay, you can take the any data here. So let me write here the new cell here. We are going to write a code here. So we are writing here. This part is already done here. Now we have to call this beanie part here, right? So first we have to define the beans here, right? After that, after the beans defined, after that we have to take the label variable defined as a name of your groups, right? So now I am going to write here. See, you can see we have defined the beans here, right? So what we are performing here, so the labels variable define the name of our group, and the pd.cut function assign each is to their appropriate groups, right? So binning can something makes important easier for the model to learn. So however, we should not automatically bin every numerical feature, because binning can also improve the useful informations. Also remove the useful informations. So now we are going to perform the log transformations. So let's discuss another important transformation we call log transformation. We call logarithmic transformation. So some numerical variable have a highly skewed distribution, like salary, income, population, transaction value, website traffic. So can something have this kind of distribution? So we have to check, how can we perform the log transformation. So now we are going to write here. So we are taking here the log salary. After that we are going to use here the log LP function. So log LP function calculate the algorithms of 1 plus. Okay, and that log transformation compress the every value. So now we are going to perform here the log transformations. So let me write this code here. Okay, so we are going to use here the log salary, and we can see here the log LP, right? And we finally going to print here the salary plus log salary, right? So log transformation compress every large value. So this can be reduce the effect of extreme value and can make highly skewed distribution easier to model, right? So now we are going to visualize the transformations. So how can we visualize the transformations? So we can visualize the transformation using this hist plot, subplot, and we have to also use this figure size, and after that we have to also use this SNS library for the different kind of plot. Okay, so I'm going to write here the perform all the kinds of plot here. You can see here we are going to perform here the log plot, and this, after that we are going to plot here. So you can see here, this is the frequency of the original salary and this is the salary, and this is the log salary we perform here. After the log transformation, this is the salary here. Okay, so we have successfully performed this log salary, log transformation. So let me explain here. So on the left we can see the original salary distributions in the figure. On the right we can see the log transform value. So this purpose of transformation is not to make the data look nice. Is the purpose of to just represent the information in front in the form of that can be more suitable for the machine learning algorithms, right? So that's why using this log transformations. Okay, so now we are going to perform the feature engineering, feature scaling, right? So let's discuss about the feature scaling. So look at the range of our features, right? And this feature have a different scale. So some machine learning algorithms are sensitive to feature magnitude. So therefore we call therefore the scaling can be very useful, right? So now for that we are going to perform the standard scaler here. Okay, so how can we perform the standard scaler here? So now we are going to perform here the standard scaler. So let me write here, we are going to perform the standard scaler on the features, right? So here we will use the standard scaler function here, right? So now I am going to write here. Okay, so you can see here these are all the features, right? And the standard scalars standardize the numerical features, and it transforms the value based on the mean and standard deviation of training data, right? So if you see the conceptual pipeline behind this feature scaling, so first we take the original value, then we subtract the mean, and then we divide it by the standard deviations. After that we are going to perform the scale value. So you can see here I'm going to write here the complete pipeline here. So this is the pipeline. You can see I'm going to write here original values, subtract the mean and divided by the standard deviation, right? If you check the mathematical formula of this, so there is a formula called z equal to x minus mean divided by the standard deviations, right? So this is the basically one formula for the calculating the standard deviations. Let me write here x equal to x minus mean divided by the standard deviations. So this is a basically formula we use here. This in the particular standard scaler, right? Okay, so after the standardizations, the feature generally centered about the 0, right? So standardization is a particularly useful for algorithms such as logic regression, support vector machine, k nearest neighbor, and k nearest neighbor, and the neural network also, and other distance gradient, right? So now we are going to understand. Now we are going to perform the mean max scaling, right? This is also important here. So we are going to perform those things here, the mean max scaling, right? So let me write here about the mean max scaling here. Let me write. Okay. So this is the popular scaling technique is the mean max scaling, right? So we are going to, in place of the standard scaler, we are going to use the mean max scaler, right? So let me write those code here. We are going to write the mean max scaler. After that, we are going to use the function mean max scaler here. So let me write here. We are writing here mean max scaler, right? So we got the feature. So what is the code? What is the meaning of this code here? So mean max scaling the generally transform the value into the fixed range and commonly 0 to 1. So conceptually minimum value is 0 and the maximum value is 1. So the choice between the standardization and the mean max scaling is depend on the machine learning algorithm and the character about the data, characteristics of the data, right? So after this we are going to perform here, if we try to compare the difference between the feature selection and feature engineering, So let's discuss here. So feature engineering and feature selection are not the same thing. So if you see the feature engineering, so we take the in the feature engineering we take the existing feature, we transform or just combine and create a new feature, right? Like we take the salary plus experience or salary per experience, this kind of feature we have developed, okay? And then the feature selections, we take the many features, choose the useful feature, and then we remove the necessary feature, right? So feature engineering creates and transform the feature, and feature selection choose which features should remain in our data set. So both techniques are important for building the effective machine learning system, right? Okay, now we are going to understand about the train and test split, right? This is the most important thing of the feature engineering here. Train test split. So let me write here the query. Let me write here in the form of text. Train test split. I'm going to write here the train test split. Or train test and split, right? So the next topic is the train test split, right? So now we are going to define here one data frame here. Again, we are going to define the data frame, okay? So, you know, we are going to take here first thing. So this is another important rule when we are doing the pre-processing or engineering features. So we should avoid allowing the information from the test set to the influence the training set, right? So now we are going to define here the one data frame here, DF, and we are inside the data frame we are putting here the age, salary, and experience, and then we are going to put the y. In the y we are putting the target. So we are putting the target using the np.array, and now we are going to just perform the test and test split, right? So let me write here. You can see on the screen here. So we are going to divide the data set into the training and test portions. So this model learned from the training data set, and this data kept separate so that we can evaluate our well the model perform on the unseen set data, okay? How the well. So now we are going to perform, now we are going to perform the correct scaling here, right? So the correct scaling, we have to fit the fit transform, right? So we have to perform the fit transform function here. So let me write here the fit transform function. We are going to write here the fit transform function here. Right? So it's giving the error like X train is not defined. Okay. So first we have to run this code. Okay. We have not run this code. So we have to run this code. After that we have to perform the standardization of data. So it's giving the error X train is not defined. Okay, now it's giving the correct data. Okay, so you can see here we notice that we are going to use the feed transform only on the training data. So the scaler learns the mean and the standard deviation from the training data, and for the test data we will use the transform, and we don't feed the scaler again on the test data. So the test data should be the simulate the completely unseen data, right? It will be completely simulate on the unseen data. So let's now bring everything together in the one practical workflow, right? So now we are going to just take the complete picture in in the particular one workflow. So how can we do that? So let me write here. First we will take the raw data, then we perform the understand about the data, then we clean the data, and after that we will check is there any numerical features. So then we transform. If there are categorical features, then we perform the encoding here, and after that we perform the data engineering, then we choose the scaling, then we go with the feature selection, then we perform the machine learning modeling, right? So let me write here in the complete workflow here. So let me write the complete workflow here. You can see this is the complete workflow. Okay. So this is the general feature engineering workflow that can follow in the practical machine learning project, right? Okay. So in this, so finally you can see here, first we converted the data column, then we extracted the year and month of week, then we created a numerical features, then we put the ratio features, then we applied the transformation, then we convert the age into the groups, and finally we convert the categorical variable using the one hot encoding. So this is what real feature engineering process look like till now. We have performed this kind of a step inside the video, right? So before finishing the today lecture, we revise the most important concept here. So feature creations, first one is the feature creation. So we can create a new feature from the existing features. Second is the feature transformations. So we can transform existing feature using the mathematical or statistical technique, right? Statistical technique, right? After that we will perform the categorical encoding. So we can convert the categorical informations into the numerical representation. After that we have performed the data feature engineering. So we can extract the useful information from the data, from the dates time stamp, right? Date feature engineering, right? After that we use the binning, right? So we convert the continuous value into meaningful group. Then we perform the scaling. So we can bring the numerical feature to just comparable the all the scale when we required, right? So finally, so what did we learn today? So we started with understanding the features, then we learned about the feature engineering means. So then we created the numerical features, then we created the ratio interaction features, then we extract the information from the date and time variable, then we converted the categorical variable using the one hot encoding, then we learned binning, right? After that we learned the logarithmic transformations, then we learned the standard scalar and min-max, then we discussed the feature selection versus feature engineering, and finally we learned the one of the most important concept is the machine learning, the data leakage, right? So we learned these things here. Okay, so remember this, feature engineering is not about to creating the hundreds of features, it's about creating the right features. So good features can be make complex machine learning problem much easier to solve. Okay, so in the next lectures, we take our prepared data and move toward the one of the most important step the machine learning is the model evaluation and validation. So if you found the lecture useful, so don't forget to like, share, subscribe the Think Lab by Saurav. So thank you for watching. I will see you in the next lecture. So happy learning.